All right, good afternoon, everyone. Sorry. Unfortunately, I move around sometimes when I talk, so I'll apologize now. So good afternoon, everyone, and last but not least, we're standing in the way of happy hour here, so we'll try to be as brief as possible. We also did the Waypoint challenge that Danny and Chris did, and our team 4 is John, myself, Roland, and John's wife Ming Fei. Ming Fei couldn't be here, unfortunately. I mean, she did a lot of the groundwork during the week, but John and Ming Fei have a child at home and it needs to be looked after, unfortunately. So she's here in spirit. Before I get too far into this, I want to thank the organizers of the hackathon and the whole program for the awesome work that they did. I mean, like, I joined this really to learn about big data technology and Apache Spark. I mean, the fact that I'm standing here in the finals is a bonus. So I'm really thrilled to be here, and I think John is too. And we both learned a lot, I think, doing the challenges and doing the workshops. So thank you. Ladies and gentlemen, for putting this together. We really gained a lot, and it was very worthwhile, all the tons of hours I put into this. Anyway, so we did the Waypoint challenge. John's a former PhD candidate and is now self-learning and boot camping and hacking his way to be a data scientist and a data analyst. Myself, I'm the lead developer and co-founder of Skywatch, which is basically an API company. We're making it easy to get Earth observation data collected by satellites. If you're more interested about that, you can come talk to me after. And then Ming Fei is a business analyst at Scotiabank. So the problem was to find locations to put the digital billboard maps throughout the city, indicating nearby attractions, and trying to find the best location within a certain distance using mapping, traffic, and demographic data. What we did was we decided to focus on two aspects of this problem. I mean, like, when we're in a hackathon, we don't have forever, I mean, we talk about what you can do with this later. Basically, we tried to pick locations that were within a certain distance of the major attractions in Toronto, cultural attractions, and then also locations that have a significant pedestrian volume. So the first data set we use is the intersection with pedestrian volumes. You can see here a visualization of all of the intersections that were measured in the City of Toronto data sets that we used to grab this information. It was collected over 5 years, and they were surveyed, or the numbers that we had were for an 8-hour period. And the second data set that we used is the cultural facilities, and basically the points that you see on the map are all the locations of the cultural facilities in the city, and these are varying cultural. Like, cultural is a very broad term, so these are a lot of different kinds of attractions. So our solution was to use a clustering algorithm to cluster the cultural facilities using their geographic coordinates. We used the centroid of each facility cluster to find the best intersection to place the waypoint. Then we would find the closest 5 intersections to that centroid, and then among those closest 5 intersections, we would pick the intersection with the largest pedestrian volume as the place to put the waypoint. So first of all, we used DB scan clustering to cluster the cultural facilities, and we found that this didn't work very well. As you can see by the black dots are the cluster centroids, and basically downtown is represented by one big dot. It wasn't very useful. So then we went to k-means, and we just eyeballed it and said, well, we think 200 would be a good number. I have to credit Danny and Chris. I mean, they actually used an algorithm to come up with an optimal number of clusters, and I'm glad that we guessed pretty close to what the optimal number was. So then we went to find the closest 5 intersections to each of the cluster centroids, and you can see from the map here the black dots are the clusteral centroids, and the blue dots are still the intersections. And then among those closest 5 intersections, we selected the one with the largest pedestrian volume as the best intersection, and the blue dots on the map are basically the areas that we came up with placements for the waypoints. And John spent quite a bit of time using what was that tool again? Floatium? Yeah, Floatium. To graph all these points on some interactive maps, which I'm going to show you. It's not my computer, so forgive me for not doing well here. Oh. Let's try it again. No, it's not what I wanted. Here. It's John's computer, he knows. Show taskbar, right? And then, yeah, there we go. See? And I did screw that up. Okay, so this is an interactive map of just the facility clusters, and it's kind of nice how with this map, as you zoom in and zoom out, you get more detail, right? And it gives you the number of cultural facilities close to that centroid point. And then as you zoom in, you get more detail. And then eventually you get the blue map markers, and that's a cultural facility, whatever that is. Well, actually, that was the facilities, actually, and now this is the centroids. So as you zoom in again, you get the centroid. You can see one there. The black points are centroids on the map. Zoom in, zoom in, zoom. There we go. See, and then you can see more black points there. Then we have a similar map with the intersections. And you can see the different intersections that were surveyed for the City of Toronto Pedestrian Volume Survey. And then our last map here is the intersections that we actually selected for waypoints. And you can see here that what we picked. If you want, how are we doing for time here? Oh, we still got 12 minutes. I mean, we could go into some of the work that we did. John did a lot of his work locally on Jupyter, and I did mine using the DataSpark platform. You can see here. How we clean the data. This is John did all the clustering work. Oop. Let's come on. Go to the side here. Yeah. All right, and then the visualizations that we did, right? Because they were all plotted. And so then the code that we used for the DB scan clustering and the results that we came up with. Yeah. Anyway. That's all the work. And then I worked on the pedestrian data, and you can see here, no RDDs were harmed in this work. I took inspiration from Jasek's presentation on Saturday and said, okay, I got to learn data frames. So I did it all using data frames. And yeah, I mean, it was like about 10 lines of code. It took about 6 hours to go 10 lines of code, but I got there. Anyway, but as I said, this was a learning experience for us, and that was the big thing. So yeah, we wanted to talk about what we could do with this data, because we realized we only intersected 2 data sets, and this is a starting point. There's a lot more data that we could bring into this that could refine this map and could refine these placements. I mean, without getting into politics. So there's still some empirical things we can do with the data. Things like the inclusion of demographic data, like going to StatsCan and pulling down some demographic data based on the local population and even the income. I mean, these waypoints just aren't going to be useful for the tourists, but hopefully for the local population as well. More data on the points of interest, like the types of facilities, like the cultural facilities map, like it was very varied and very large. It was things from, churches to tourist areas and everything in between. So maybe to drill down a little more on what those facilities were and maybe to get more accurate information on that. The area, again, that kind of goes into the areas of interest. And then another thing that we didn't consider was accessibility to transit, rapid transit in particular. Because you want to put these things in places where people are going to walk by them, or when they get off a bus or get off a streetcar or get out of the subway, they know where to go. So, any questions?
Thank you very much for the presentation. I wonder if I can ask you if you can go back to the slide where you started landing on your suggested intersections that you would recommend for a slide. And I'll take the same question that Jeff had. Did they pass the smell test for you? Was there some things you just shook your head and said, it's not where I would land?
I think from your when you get out into the suburbs a little bit, because like our distribution ended up being pretty spread out, kind of surprisingly, because we thought everything would end up downtown, right?
Another problem is that we only select like 200 points. That's just a starting point. If you increase the number of clusters, then you will see that we can get more. Then we put 300 maps. That's going to cover more places. Yeah. So that's just a simple problem of how many clusters you pick. Yeah.
Yeah. So I mean, if you look at some of the locations we came up with, I mean, you look at here. It should be a waypoint somewhere on Leslie Street. I think there's a hotel there or something like that. In that area of Leslie. Or it's actually very close to the park there, E.T. Seton, which is probably why there's a large amount of pedestrian data there, right? Maybe not something that you thought of, and I think that comes to the amount of variation that you have in what a cultural facility is, right? Bayview Avenue, like that's near Sunnybrook, for example. That where I've got the hand right there. Again, it's a hospital, right? I mean, it's a beautiful area around there, but again, it could be, the pedestrian volume could be just because of the hospital. Cultural facility that's there, well, I don't know. So there were some surprises, especially when you got out to the suburbs a bit. So yeah, but I mean, like I think we, when you look at downtown, I think a lot of the locations that we came up with made sense, but out in the suburbs it got a little dicey, I think.
In terms of using the intersection pedestrian traffic data, is there a way to filter or clean that up to separate the regulars? Like 5 days a week, I'm walking through that intersection and it's busy, versus the infrequent, I'm there once. Whether I'm a tourist or whether I came from Vaughan and drove down, but I'm not regular, so I'm the guy who needs the direction. So instead of going on total mass, it's the separate the lost from the found.
Yeah. Unfortunately, no. The City of Toronto data was not that granular. It was just basically a number in an 8-hour period. And it wasn't further classified than that. I mean, it's, the data was gathered manually, my understanding. I mean, it's basically someone there with a clicker, right? So the efficacy of that data might be in question a little bit. It's also measured over, for an 8-hour period, but each intersection was done on different days. So it could be, you could run into trouble if, in December versus July, for example, depending on the location. And then it was 8 hours over a 13-hour period because the people doing the clicking took breaks, right? So you know, it would be nice to have way more accurate data in terms of the pedestrian traffic, but you know, you work with what you have, right? And I think we came up with some pretty logical placements based on the data that we had, and others that were maybe a little surprising, you know, as I said before. So. We understand the data was collected on a weekday, so they were weekdays and non-holidays. So,
They were not holidays.
yeah,
Maybe the holidays would actually demark the found and the loss. Usually people lost on weekends.
yeah, that's possible. But I mean,
It's not there.
yeah, we don't have that level of detail. Danny.
I noticed that when you were using your interactive map, and when you were hovering over some sessions, there was a sort of a blue highlighted.
Yeah, I think that's just the software we're using. It's Leaflet, right? So like there's a polygon drawing algorithm in there, right? And I think I was just scanning it the wrong way. It doesn't do anything. Yes.
I'm curious to know how, because you use a supervised or unsupervised process like k-means and dbScan to kind of identify clusters based on kind of the patterns of data. How would you make this a supervised process? What would you look for, or what kind of labels, or what would your criteria be for, say, I know based on just business or city planning intuition, there should be a sign there, and then now use that to fine tune your unsupervised process.
Yeah, that would be an interesting process, because I mean, in talking to Fiona, I mean, like they came up with, they used consultants and came up with very, what you would call common sense locations for where these things are. And it'd be interesting to compare our results to what you came up with to see, it would be a measure of the accuracy of the model, right? And I think that would be a really good exercise. Yeah. Any other questions?
Well, I think on the flip side, the utility of your model and then this model would be that you would give city roadmap to sort of pick the location that they should spend and helping out and look closer at the physical time that is sort of if they don't have a roadmap and they can decide what to do.
One of the things, sorry, just weigh in on that. One of our suggested approaches at this point in time, and a lot of this, of course, is partner-led, right? I want something in my area, is to look at it at that kind of grid level, and make those decisions at a more micro one, rather than just say across the board, whatever. So so much of this is partner-led at the outset, so it makes it a little less rational, to be really honest.
I guess one last question is, with about 200 or so optimal points, what would be the strategy that you would advise to kind of roll out both, where should we start placing signs first, and then how do we validate our actual algorithm that said that these are the great best spots to put the signs?
I think in terms of where, I think we probably could have done a little more work and maybe ranked them by volume. Which we didn't do. And then, I'm sorry, the second part of your question was?
And then how would you, as you say, we're going to put 50 signs down first, and you've chosen a strategy to do that, how would you assess, how would you validate, based on, say, changes in behavior or whatever, how would you know that these are, in fact, the right places, and how would you measure the behavioral impact of those signage places?
Yeah, again, there that would have to be, by observation. I think, one of the earlier presentations alluded to A/B testing, and I think that might be a useful strategy here. You put it in a location and or observe the location before the sign's placed and observe people's behavior, and then place the sign and observe people's behavior afterwards and compare the two. Kind of like have a valid A/B test. I think that would probably be a good way to evaluate whether or not it's the right location. That it? We can go a happy hour. All right.